Okay, let's understand how to create. Okay, guys, let's understand how to create 3-bit up counter using JK flip-flops. So it's a 3-bit up counter using JK. Okay, so whenever you're trying to design any counter, there are certain things you need to remember. The first thing is you need to draw the state diagram and then draw the state table, and then you have to derive the flip-flop inputs using K-map, and then you have to design the circuit. Okay, so these are the things what you need to follow. So let's create the state diagram. Since we are going for a 3-bit up counter, 3-bit means you can have 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, so on. This is the counting sequence. So it keeps on counting like 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 means again it goes back to 0. This would be the state diagram. Like you can just put the circles on it and you can just show. This would be the state diagram. Next, you're going to write the state table. So since we're going to use a binary encoding, okay, we'll be using a binary encoding to encode the states. Let states 0 be represented as 0, 0, 0 because it's a 3-bit counter, right? So 1 is 0, 0, 1, 2 is 0, 1, 0, 3 is 0, 1, 1, and 4 is 1, 0, 0, 5 is 1, 0, 1, 6 is 1, 1, 0, and then 7 is 1, 1, 1. So how do you write a state table? Okay, so let's write the state table. So let the present state be Q2, Q1 and Q0. Okay, so let the next state be Q2 plus, Q1 plus and Q0 plus. Okay, so you can also write like QA, QB, QC, whatever the naming convention you are comfortable with. So 3 bits, hence I'm using Q2, Q1 and Q0. Okay, so before writing the state table, you also need to know something called as excitation table. So what do you mean by excitation table? You should know, like if you're designing with a JK flip-flop, so if you know your counter should behave this way, which means accordingly the state also should move in that direction. So if Q and Q plus are denoted by present state and next state, if it is a JK flip-flop, right, you have to know what are the flip-flop inputs. If 0 to 0 you want a transition, then what should be JK? So 0, 0, 0, 1, 1, 0 and 1, 1. So what is JK? If it is 0, 0, 0x, 0, 1, 1x, 1, 0, x1, 1, 1, x0. Okay, so this way you can write for JK, SR, DET or whatever. So this is just for a JK flip-flop. Okay, let's from this just remember we'll derive it. Okay, okay, so this is excitation table. So let's write the state table now. Okay, so let me write present state as Q2, Q1, Q0. Since it's an up counter, then I'll write Q2 plus, Q1 plus and Q0 plus, the next state. And let's understand, okay, let's see like J2, K2, J1, K1 and J0, K0 would be the flip-flop inputs, okay. So 3-bit up counter, right? So let's write in all the states. We'll just follow the same sequence 0 to 7 because it helps in minimizing the expression using K-map. Okay, so 0, 0, 0, like this is 0, 1, 2, 3, 4, 5, 6, 7. What is 0? From 0, the next state is 1. So 0 is 0, 0, 0, 1 is 0, 0, 1. Let's map it accordingly. So this is going to be 1. From 1 it's going to be 2. From 2 it's going to be 3. From 3 it's going to be 4. From 4 to 5. 5 to 6. 6 to 7. From 7 back to 0. Okay, so once you have written the present state and next state, so let's map the things in binary. So how do you create, what do you mean by J2, K2? So J2, K2 are the inputs of a flip-flop whose output is Q2. J1, K1 is the input of flip-flop, and J0, K0 is the input of flip-flop whose output is Q0. So next, find out what is J2, K2. So what for that you have to compare Q2 and Q2 plus. You can see 0 to 0. As you see in the excitation table, if 0 to 0 is a transition, my flip-flop input should be 0x. So what I'll do here is 0 to 0, 0x. You can see here next 0 to 0, again 0x, 0 to 0, 0x, and now you can see this is 0 and this is 1. So 0 to 1 is, if you want you can just have a look here, 0 to 1 is 1x. Again 1 to 1 is x0, 1 to 1 is x0, 1 to 1 is x0, and 1 to 0 is x1. Okay, so let's find out what are J1 and K1. For J1 and K1, you know now you have to compare Q1 and Q1 plus. So you can see 0 to 0, 0x, 0 to 1, 1x, 1 to 1, x0, 1 to 0, x1, again 0 to 0, 0x, 0 to 1, 1x, 1 to 1, x0, 1 to 0, x1. So let's find out what are J0 and K0. For J0 and K0, you have to compare Q0 and Q0 plus. You can see everything is like 0 to 1, 1 to 0, 0 to 1, 1 to 0. So 0 to 1 is 1x, 1 to 0 is x1. So it just goes on. I'm comparing Q0 and Q0 plus. So 1x, x1, 1x, x1. So we are now done with the state table. So let's find out what are the flip-flop inputs. So I have to map J2, K2, everything in your K map. So how will you do that? So what you should do here, your flip-flop, okay, for to write the K map, your inputs are your Q2, Q1 and Q0. So let's find out what is the K map for J2, because we need to find out what are the flip-flop inputs. Okay, I'll just keep it this way. You can see. Okay, so what you should do here is you have to put a K map for a 3 variable K map. Okay, so it's going to be Q2, Q1, Q0. So 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So what is J2? 0, 0, 0, 1, 0, 0, 0, 1, XX, XX. You can see I've just mapped J2. So what is this? This is going to be Q1, Q0. So what did we get J2 as? Q1, Q0. Okay. Similarly, we'll find what is for K2. I'm mapping for K2 now. Again, your inputs are Q2, Q1 and Q0. 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So K2 is, you can see, XX, XX, 0, 0, 0, 1, 0, 0, 0, 1. So you can map these two. So Q1, Q0. So what is K2? K2 is also Q1, Q0. So we are done with J2 and K2. Next, we'll map it for J1 and K1. You can see it is 0, 1, XX, 0, 1, XX. So for J1, okay, so it's going to be 0, 1, XX, 0, 1, XX. So I can group these four. So what I'll get is Q0. So the common is Q0, these two. So what is J1? It is Q0. Similarly, what is K1? K1 If you want, you can just see here what is K1, XX01, XX01. So I'll just map it, XX01. So you can it's same. So this is also Q0. So K1 is also Q0. Now let's figure it out what is J0 and K0. You can see every term here is 1x, 1x. So you can group all the things, and all the minterms in your K map. So if you can group all the minterms for J0 and K0, yeah, your inputs are going to be 1. J0 is also is equal to 1, K0 is equal to 1. Why? Because you will be able to group all the 8 minterms, because either you have 1x, 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 1x. It's something like this, so you can group it. Okay. So now you know what is J2, K2, J1, K1 and J0, K0. So what we will do is we'll create the circuit. So what I'll do is I'll just try to erase this and I'll write here itself. Okay. So schematic. Okay, so what are the flip-flop inputs? So and all the flip-flops are common, means having a common clock. So you can just write like this, clock, and this is J2, K2. This is going to be J1, K1, and this is going to be J0 and K0. So what are the outputs? Q2, Q2 bar. I'm not interested in Q2 bar. Q1, Q1 bar, and then Q0 and Q0 bar. So what is J0, K0? It is 1. So what I'll do is I'll tie this J0, K0 to 1. Okay, give 1. What is J1, K1? I think J1, K1. You saw we got J1, K1 as what? Q0 itself, right? J1, K1 as Q0. So what I can do is you can connect it like this. Okay. And what is J2, K2? It's Q1 and Q0. So what I'll do is I'll put an AND gate here. So J2, K2 is Q1, Q0. So where is your Q1? Your Q1 can come here. Okay, what is Q0? Your Q0 is this, right? That's it.